Hi everyone, this is Kishore. Please subscribe my channel for more videos. Okay, today we are going to discussing about Kirchhoff laws. Okay, Kirchhoff laws. So coming to the Kirchhoff laws, according to the calculation of both voltage and current, there are two types of Kirchhoff laws is there. In that, one is the Kirchhoff current law. One is the Kirchhoff current law. Okay, current law, as well as, and second one is the Kirchhoff voltage law. And second one is the Kirchhoff voltage law. Okay, Kirchhoff voltage law. So coming to the both Kirchhoff current law and Kirchhoff voltage law, which is based on, let us consider for the different types of circuits, different types of both active element circuits as well as passive element circuits. Okay, so here coming to the coming to the Kirchhoff current law, let us consider one node point. Okay, so this is the node point. NODE, node point. Okay, so first of all, what is the mean itself node? What is the meaning of node? Node means the connection between the any two points or any two elements. Elements means that is like the passive elements or active elements. Okay, the connection between any two elements or any two nodes is called as, any 2 points in or any two elements is called as, simply you can call it as node. Okay, so here, so from that node there are different types of currents is there. Some currents is entering to this node, some currents is entering to this nodes. Okay, so that is given as some I1 current and I2 current, some I3 current, like that, etc. And also some currents is leaving from that node. Okay, that is given as like a I4 and like some I5. Different types of currents is leaving from that node, and different types of currents is entering to the node. Different types of currents is entering to the nodes, as well as different types of currents is leaving to the nodes. So leaving to these nodes is I4 and I5, like I6, etc. Different types of currents is leaving. Okay, so from this instant of different types of currents, we can simply draw the one equation. You can simply derive the one equation. That is given as here. So from this instant of different types of currents, we can simply just the equations of the definition of Kirchhoff current law. Okay, here from this total entire diagram, we can simply say that sum of entering current. Okay, sum of entering currents, different types of currents. Here I1 and I2 and I3. Sum of entering current is entering into the junction of current. Sum of entering current to the junction of node, as well as sum of leaving currents from the load. Okay, are also called as sum of entering currents to the junction, as well as sum of outgoing from the junction. Which is called as Kirchhoff law. Okay, I think, are you understood? I think maybe you are understood. Sum of entering current to the junction as well as sum of outgoing from the junction is called as Kirchhoff current law. This is a notation of the Kirchhoff current law. Okay, so from this total diagram, we can simply draw the equation. Here entering currents is I1 and I2 and I3. Okay, that is given as the combination, all are entering to the node. So that's why here given as plus I1 and I2 and I3. Okay, so this is the entering, as well as some leaving currents is there, that is I4 and I5 and I6. If you have this diagram, you can clearly understood. Okay, I4 and I5 and I6, that is the leaving current from the particular node. So that is given as, so these are the plus, and second one, next one, leaving currents I4 and I5 I6, that is given as minus. Why? Because which is leaving from the node, so that's why we are generally putting minus I4 and minus I5 and minus I6. So this is the equation for the Kirchhoff current law. Okay, this is the equation for the Kirchhoff current law. As well as coming to the Kirchhoff voltage law. Okay, so basically the Kirchhoff current law, which is used to measure the current in that particular circuit, measure complex circuits. Okay, as well as coming to the Kirchhoff voltage law, in the Kirchhoff voltage law, which is used to measure the voltage in that particular circuit, total circuit. Okay, for example, let us consider one circuit. Okay, so let us consider one circuit. So this is the summary system, the combination of passive elements as well as active elements. For example, let us consider one circuit. The circuit may contains both combination of passive elements as well as active elements. Okay, passive elements means resistance, inductance, and like some capacitance, Okay, so and also may contain some active elements also there. So that is like a battery. That is best example for them. Active element is the batteries. Okay, so battery symbol is like this. One is the positive plate and another one is the negative plate. Okay, and also another battery also there here. Another battery also there. So this is the capacitor. This is the battery B. So this is the resistance which is indicated as R, and the inductance which is indicated as L, and the battery. This is battery. So B1 battery means a supply. So with the help of battery, so in any way at any circuits we are generally fed into the supply. Okay, so that's why which is given as some V. V is the best. V and V1 and V2. Simply we can call it as V1 battery and V2 battery. Okay. So this is like a circuit. This is like a circuit representation in a closed loop circuit. Okay, because here there is no open at any point. Here no open at the any point, which is the symbol of battery. Not open between the two plates. Not open between the any two plates. This is the symbol of battery. Okay, so this is the total circuit which is actually like a closed loop path. The total circuit which is actually like a closed loop path. Okay, in a closed loop circuit, the total voltages must be equal to 0. Okay. In a closed loop circuit, the total voltage, here there are two voltage sources there. Here there is two voltage sources there if you observe the circuit diagram. Okay, one is the V1 battery and second one is the V2. These are called as two voltage source. Okay, why? Because from this voltage source we are generally fed into the supply to the all network elements. Okay, all network elements are all passive elements. Okay, in a closed loop circuit, all voltage source must be equal to 0. So that is given as V1 and V2, both V1 plus V1 and V2 which is equal to 0. Okay, when we are which is equal to 0 to the both V1 and V2 are different types of voltage source. If the circuit may contain different types of voltage source, all voltage source must be equal to, we can easily to 0. So then only which is satisfied to the Kirchhoff voltage law. Then only satisfied to the Kirchhoff voltage law. Okay, so the definition of Kirchhoff voltage law which is given as in a closed loop circuit, the total voltage source must be equal to 0. That is called as Kirchhoff voltage law. Okay, so thank you. So this is the basic definitions for the Kirchhoff voltage law and Kirchhoff current law. For more videos, please subscribe my channel. So thank you very much. Thank you.